Hello everyone, welcome to GTQ Gate Through Questions for the Electronics Engineering. Subject is your EMT. So let's begin with the first question. The first question is, in an electromagnetic region, the electric field and magnetic fields are given as some electric field and magnetic field has been given. The average flow density of power. So this is watt per meter square. So the average flow density of power is how much? Correct? Okay. So here let us go for the solution. Here what you can observe here, electric field is given as 10 times JAX plus 2 times of AY minus J times of AZ e to the power j omega t. Correct? H vector, it is equal to minus of AX cap plus of J times of AY plus AZ e to the power j omega t, right? So this is the data we can obtain from here. Now we have both electric field and magnetic field that has been given. So from here what I can do is I can get the value of H conjugate. This is equal to minus of AX minus of J times of AY plus of AZ e to the power minus j omega t, right? Fine. So what I can do is I can go for E cross H conjugate. Correct? So if I do E cross H conjugate, so this is 10, this is a JAX plus 2 times AY minus of J times of AZ cap e to the power j omega t cross. H vector is how much? Minus of AX minus of J times of AY plus of AZ e to the power minus j omega t. Correct? So you can see that if I do the cross product, the vectors will get crossed and these magnitudes e to the power j omega t and e to the power minus j omega t, it will nullify. So I can rearrange this in this fashion. This can be rewritten like this. So this is same as 10 AX cap AY cap AZ cap, right? So this is your AX, this is your J, this is your 2, this is minus of J, minus of 1, minus of J, and this is 1. Correct? Now this can be written as 10. Let us consider first AX. So this is 2 minus, so minus minus plus J square, it is minus, so minus 1. This is minus AY. If I take AY, this is J into 1 is J minus, so AY, this is minus minus plus, so into J plus AZ. If I take AZ, so J into J, it is minus, so minus minus plus 1 minus, so I am taking AZ, so J into J is minus minus plus minus 2 into minus 1 is minus 2, so plus 2. Correct? So this is the value I am going to get, right? So this is how much? So this is equal to 10 3AX. You can see that this term is getting cancelled because this is J minus 0, it is equal to 0. So this is your plus 3 times of AZ, right? So therefore to find the power, what we do? So to find the average power flow density, so P average, I can find it like this, half of real times E cross H conjugate. Correct? So if I take the magnitude, because in the question if you see that they have asked only the magnitude, so in there is no direction they have given, so that means I have to take the magnitude. Correct? This is equal to half of, right? Now this is, there is no imaginary term, so this is in the real format, so you have to take the magnitude, that means this is a 10 multiplied by this is 3 root 2, right? So either you can do 3 square plus 3 square, that is 18. 18 root is how much? It is 3 root 2. Now I need a calculator to solve this. So this is how much? So you can observe here, this is 2 into 10, sorry 10 divided by 2, it is 5. So this is a 15 root 2. So I am going to get this value as 21.21 watt per meter square, right? So in the question they are asking that the average flow density, and if you see that the unit has been given in watt per meter square, that means they are talking about the power. So power will be how much? the power density, so the answer should be 21.21 watt per meter square. I hope it is clear to everyone. Right. So next let us go for the next question. The next question says that a uniform plane wave in air partially reflects from the surface of a material whose properties are unknown. Measurements of the electric field in front of the interface region yield a 1.5 meter spacing between maxima, with the first maximum occurring 0.75 meter from the interface. A standing wave ratio of 5 is measured. The intrinsic impedance eta w of the unknown material is what? Right. Now what I can see here, so let us try to figure out. Let us say this is the z axis, right, and which field they have mentioned, whose property, measurement of electric field. So this is the electric field. So this is the E max, let us consider, and this is the E minima, correct. Now the standing wave, how much they want? Standing wave ratio should be 5. So let us assume that the maximum electric field is 5 and the minimum is 1, so that the standing wave ratio is how much? It is 5, right. You can take 10 and 2 also, you can take E max as 10 and E minimum as 2, because their standing wave ratio S is nothing but your maximum upon minimum fields, right. Now here what you can observe here in the question, if you see there is a standing wave material whose properties are unknown, measurements of the electric fields in front of the interface. So this is the interface. So in front of the interface the standing wave has been made such that 1.5 meter spacing between maxima, with the first maxima occurring at 0.75, right. So first maxima is occurring where? So first maxima is occurring at 0.75, right. So therefore this is how the first maxima, so this is how we can plot the graph, right. And if I draw this point, so what in the question what they have mentioned is, they have mentioned that the distance between these two, right, is your how much? 1.5 meter, correct, right. So how much it is given? So distance is how much? It is given as 1.5. So if I add 1.5 with 0.75, how much value we are going to get? So that means this value will be 2.25. This value will be a 2.25, right. So this value is a 2.25 and this value is a 0.75, right. So if you read the question and try to make the diagram, so this is what you are going to get. So a uniform plane wave in air, right. So which medium is this one? This is your air medium, reflects from the surface of a material whose, now this is your unknown medium, right. This is given as unknown medium, correct. So this is your unknown medium. Measurements of the electric field in front of the interface yields a 1.5 separation between maxima, right. So any two maxima, if you consider, there is a separation of 1.5 meter, correct, with the first maxima occurring at 0.75 meter from the interface. A standing wave ratio is 5, it is given. They are asking what is the value of intrinsic impedance, eta w is how much. So this is the question, right. Now how to find this value? So here what you can observe here is S is given as how much? It is given as 5. So what is the value of mod of gamma? Mod of gamma is equal to S minus 1 upon S plus 1. This is your 5 minus 1 upon 5 plus 1. So this is equal to 4 upon 6, which is equal to 2 by 3, right. So here gamma can be anything plus minus, right. So gamma can be anything between plus 2 by 3 or minus 2 by 3. Now here we have to be assured that whether the gamma should be positive or negative. So there are two ways. There are two ways to judge whether the gamma should be positive or negative, right. So I will give you the method one, how you will come to know whether gamma is positive or not. So you can see that according to the question, the first maxima, that is 2 beta z maxima, is what is the formula? 2n plus theta gamma, right? So this is the formula of maxima, right? Now here what you can see that this lambda by 2 is how much? It is given as 1.5. How do I know? Because we know that the distance between any two maxima are lambda by 2. So therefore what is the value of lambda? Lambda is equal to 3, isn't it? So therefore I can write it like this also, 4 pi upon lambda into z max is equal to 2n pi plus theta gamma, correct? So from here what I can say that 4 pi upon lambda is how much? It is 3, and first maxima is occurring at 0.75 minus of 2n pi, right, is equal to theta gamma. Can I write it like this? Now if I have taken, or rather you can do like this also, one second, I will write one more step so that it will become easy for you to understand. So I can write it like this also, 4 pi z maxima upon lambda minus of 2n pi is equal to theta gamma. First maxima is occurring at 0.75 meter, it is given in the question. So if I put n equal to 0, right, n equal to 0, so I am going to get theta gamma is equal to 4 pi upon lambda into z max. Always remember that mod of theta gamma should lie between 180 degree, right? So that means you can take any values of n. It is not that you can take only 0 values. You can take any value of n. N can be taken as 0, 1, 2, whatever you want to take, you can take. But the condition is that whenever you evaluate theta gamma, right, so whenever you evaluate theta gamma, so mod of theta gamma should lie between 180 degree. That means whatever be the angle is there, suppose it is lying outside the minus 180 to plus 180 range, so you have to add or subtract 360 degree so that it comes under minus 180 to plus 180, right? So simple is, if I put n equal to 0, I will directly get the value which is less than or equal to mod of theta gamma is less than equal to 180 degree. So therefore I can say that theta gamma is equal to 4 pi, lambda is how much? 3, z maxima is how much? 0.75, right? So this is how much? This is pi, because 0.75 into 4 is how much? It is 3 only, correct? So this is pi. So therefore I am getting theta gamma is equal to pi. So what does this signify? It signifies that gamma should be negative, right? It signifies that gamma is negative. So this is one way to find whether gamma is positive or negative. Let us go for one more method where we can solve graphically whether the gamma should be negative or positive, right? Right. So this is the thing, correct? So let me, one second. Fine. Let us go for method number 2. I hope things are clear till here, everyone. Okay. So next, method number 2. Method number 2, I will solve graphically, right? That means without going for this much of calculation, directly we can see what should be the value of gamma. How? See here, 0.75, right? So this is 1.5. That means if I see the minima here, right? So this minima and this minima, how much will be this distance? You will say that this is also 0.75 and this is also 0.75, right? Because minima will occur in midway of the two maximas. So this is 0.75 and the total distance is 1.5. So that means minima will be where? Minima will be at 0.75 plus 0.75, right? And that means it is at 1.5. And again the next maxima is occurring at 2.25, correct? It means that this is the minima which is occurring at what distance? 0.75. So if I extrapolate this graph, that means 0.75. So here I am going to get the minima, right? So here I am going to get the minima. So that means if I extrapolate the graph, it will become like this, because this distance is how much? This distance is a 0.75. So that means if from maxima the minima is occurring at 0.75 in this side, so on the right side also the minima will occur at 0.75 distance. So that means 0.7 means what? It is the minima is occurring at what point? The minima is occurring at this point. It means that, so if this is the minima, it means that theta gamma is going to give the negative value, right? So theta gamma is going to give you the negative value. So, or you can say that from here I can see that the V minima is at the load end. So, that means theta gamma will be negative. So, gamma is negative, right. So, here you can see that this is the V minima or E minima, you can say that. So, this is the E minima at interface, E minima at interface, right. So, if E minima is at interface, it means that theta gamma is equal to pi, right. So, therefore, I can say that gamma is your negative, correct. Fine. So, this is the value I am going to get. So, what they are asking? They are asking the medium. So, I will take gamma to be minus 2 by 3, right. So, graphically also we have got. So, what is the value of gamma? Gamma is equal to eta 2 minus eta 1 upon eta 2 plus of eta 1. So, this is nothing but your eta w minus of eta air divided by eta w plus of eta air, right. So, from here I will get the value of eta w as eta air into 1 plus gamma upon 1 minus gamma. Eta air is your 120 pi, 1 gamma is how much? So, I have to select gamma to be negative. So, 1 minus 2 by 3 upon 1 plus 2 by 3, right. So, this is how much? This is a 120 pi, this is your 1 by 3 upon 5 by 3, isn't it? Correct. So, this is your how much? It is your 24 pi. Fine. So, how much I am going to get the value? So, it is a 24 pi ohm is the answer. So, this should be the answer. I hope everybody is clear with this. Right. Okay. So, this is the answer to this question. Now, coming to the next question. This is the next question. Power density of a thin dipole antenna is given by P equal to K upon R square sin square theta watt per meter square, where K is a constant. The directivity of antenna in dB is how much, right? So, how to find this? Right. Now, see what it is given, P, it is given as K upon R square sin square theta, right, watt per meter square, where K is your constant. Correct. They are asking directivity. Now, in dB, okay, so what is directivity? Directivity is given as 4 pi upon beam solid angle, right? And what is beam solid? Sorry, this is your beam solid angle. So, this is your beam solid angle is given as un theta comma phi into d omega, right? Now, we have to find the normalized value of the radiation intensity, correct? Now, what we have to do over here is, now as radiation intensity u theta comma phi is given as r square into p average. It means that radiation intensity is directly proportional to the power, right? Or you can directly write like this also. You can directly write that as radiation intensity is directly proportional to the power, right? It means that, so power is given. So, I can say that u theta comma phi is equal to P, watt per meter square is given. So, let us say there is some constant, let us say this is C times K upon R square sin square theta, correct? What is C? C is a proportionality constant. Let us assume It is a proportionality constant. Let us assume, correct. So u theta comma phi is directly proportional to p. That means I can say that this is u is equal to some c into p. Can I write it like this? Right. Now, what is your u theta comma phi maximum? U theta comma phi maximum. What can be the maximum value of this function? So maximum value will occur when sin theta becomes 1 or sin square theta becomes 1. So this will become c times k upon r square when at theta is equal to pi by 2, because sin pi by 2 is how much? It is 1, right. So what is the normalized value of the radiation intensity? So un theta comma phi, it is equal to u theta comma phi upon its maximum value, that is u max. So if you divide it u theta comma phi upon u theta max, so this is nothing but your sin square theta, right, because all the terms are getting cancelled, right. So this is the value you are going to get. So once you have got the un theta comma phi, and this d omega is nothing but your solid angle, differential solid angle. So therefore what I can do is, so right, so beam solid angle, it is your how much? So it is your integration of un theta comma phi into d omega. This is equal to un theta comma phi is how much? It is your sin square theta, right, into what is d omega? It is your sin theta d phi, correct. So this is the value I am going to get. So therefore this is equal to how much? It is your sin cube theta d theta integration of d phi. Phi is from where to where? 0 to 2 pi, and theta is from where to where? 0 to pi. Now this integration I can do it like this also. This is your 1 minus cos square theta into d times minus cos theta. Can I write it like this? Because 1 minus cos square theta is your sin square theta and left is sin theta. So sin theta can be written as d of minus of cos theta. So this can be written like this mathematically. So from here theta 0 to pi, and this is an integration of d phi. Phi is equal to 0 to 2 pi. Can I write it like this? Right, because sin cube theta can be broken into two parts, sin square theta into sin theta. Sin square theta is nothing but your 1 minus cos square theta, and sin theta can be written as d of minus cos theta. So when you integrate it, you will get this value as 4 by 3, and this is 2 pi. So this is how much? It is equal to 8 pi by 3. Now this is simple integration. You can easily obtain this integration, and in antenna part or in directivity, in the majority of the question you will find this kind of sin cube theta d theta from 0 to pi. So in maximum question you will get this kind of values. So obviously this is the standard result. You can remember 4 by 3 is the answer, right. Now this is your 8 pi by 3, fine. So therefore what is the directivity? Directivity is equal to 4 pi upon beam solid angle. So 4 pi upon 8 pi into 3. So this is how much? It is equal to 1.5, because this is 4 2s are 8. So 3 by 2. Now they are asking directivity in dB. So what is directivity in dB? It is equal to 10 log base 10 into d, that is 1.5. So we need calculator to find the value. So calculator is so we have to find the value of log 1.5 into 10. It is 1.76. It is your 1.76 dB. So this is NAT, I guess, right? So this is NAT. Yeah. So answer is 1.76. So this should be the answer. Correct? Now coming to the next question. This is the question. A uniform plane wave is traveling in a dielectric medium with epsilon is equal to 4 epsilon naught, mu is equal to mu naught, having field H incident is equal to 0.4 e to the power j 10 to the power 90 minus 3x minus 3 root 6 z ay ampere per meter incident on air boundary as shown, correct. So here the data has been given and even the diagram has been given. So you can see that the below one is your air, above is your lossless dielectric, right? Correct statements is or are. So this is your MSQ actually. So this question is your MSQ, that means multiple select question. So more than one answer can be correct, right? So we have to be careful while getting the value. So more than one or more than one can be correct answer. So this is the question that has been given. Now what they are asking is that the incident angle theta I will be how much, correct? Now what you can observe here is theta I they are asking. So one by one, the first, let us find the solution to this question. First option, they are asking what is the theta I. I'll try to redraw the diagram here. This is given as x-axis, this is given as z-axis, correct? This is the incident theta I, fine. This is how the wave is coming. Now what I can see here is, let us say this angle is a 90 degree, there is no doubt about it. So how much will be this angle? You will say that this angle will be your 90 minus of theta I, there is no doubt about it, correct? So this angle is 90 minus theta. How the wave is propagating? The wave is propagating in this direction, right? Or let us say the direction of wave propagation. The wave is propagating in this particular direction, right? So this is nothing but your beta vector. So this beta vector can be broken into two components, one component vertical, another component horizontal. Can I break this into two components? Yes. So this component will be how much? Now since it is in x direction, so this is your beta x in the direction of ax, and this is your beta z in the direction of az, right? Correct? Fine. Now what the question given is that given hi vector is equal to 0.4 e to the power j 10 to the power 90 minus of 3x minus of 3 root 6z. I hope it is in the AY direction. So let me check once whether I have written correct or not. So hi is equal to 0.4 e to the power j 10 to the power 90 minus 3x minus 3 root 6 z ay, correct, right? So I can I write it like this? This is same as 0.4 e to the power j 10 to the power 90 minus, can I write it like this? 3x plus 3 root 6 z in the direction of ay. So this is nothing but your, in which format it is now? It is your e to the power j omega t minus of beta dot r in the direction of ay, correct? So this equation is given in this format. So what we can infer here is, what is beta dot r? So therefore what is your beta dot r? So beta dot r is equal to 3x plus 3 root 6z, right? So from here I can say that beta dot r can be written as 3ax plus 3 root 6 az dot r vector is your x-ax plus z-az. Can I write it like this? So beta dot r. So from here I can get the value of beta vector. So beta vector is how much? 3ax plus 3 root 6 az, right? So I am showing you the solution elaborately, right? So I am not using any kind of shortcuts. I am just giving you the conventional approach, because you know, to practice you should have each and every point clear. So that is why I am writing like this, right? When you are versed perfectly with this, then you can directly see what is the value of beta, right? It means that, so this is nothing but your beta x in the direction of ax plus beta z in the direction of az. Can I write it like this? So from here what you have observed that beta x is how much? It is 3, and beta z is how much? 3 root 6, right? So that means indirectly or directly you can say that I know these values, right? I know these values. Is it? So from the diagram, what I can see? So I can say that cot of 90 minus theta I, correct, or not cot, directly you can write tan, right? So later on we can find. So tan theta is equal to perpendicular upon base. So perpendicular is how much? It is mod of beta z, and base is how much? Mod of beta x, correct? So tan theta is equal to perpendicular upon base. So beta z is how much? It is your 3 root 6 divided by 3. So this is how much? It is root 6, isn't it? So therefore I can say that cot of theta I is equal to root of 6. So therefore tan of theta I is equal to 1 by root 6. So from here I can directly find the value of theta I, correct? So let us use the calculator to get the value. So this is your tan inverse 1 divided by root 6. So I am getting 22.20 degree. 22.20 degree should be the correct answer. So let us see whether option A is correct or wrong. Option A, the option is given as 30 degrees. That means it is absolutely wrong. So it cannot be the answer because A is not 30 degree. I am getting 22.20 degree, right? Next we have transmitted angle. Let us see B. Transmitted angle means this is theta t, isn't it? So this will be your theta t. So they are asking what will be the transmitted angle, correct? So option A is wrong, correct? So option A is wrong. Now coming to the option number B, which is asking your transmitted angle, option B, they are asking theta t. Let us see whether it is correct or not. So to find the theta t, we have to use which law? Snell's law, right? We need to use Snell's law. Means this is the x-axis, this is the x-axis, this is the z-axis given in the question. Now wave is coming from here and it is going like this, right? This angle theta I know that it is coming to be 22.20 degree. They are asking what is the value of theta t. Here epsilon value is given as 4 times of epsilon naught and mu value is given as mu naught. Am I correct? Let us see. Let us see here. Epsilon is equal to how much? Where is the diagram? Yeah, 4 epsilon naught mu naught, and this is epsilon and mu naught, right? So this is your epsilon is equal to epsilon naught and mu is equal to mu naught, correct? So what does Snell's law says? That Snell's law says that n1 into sine theta I is equal to n2 into sine theta t, where n is nothing but your refractive index, and we know that refractive index is nothing but your, it is related with the dielectric, which is equal to root under epsilon r, right? So refractive index is directly proportional to the permittivity of the medium, right? So therefore I can say that this is a root under epsilon 1 into sine theta I is equal to root under epsilon 2 into sine theta t. So epsilon 1 is your 2 multiplied by sine theta I, that is sine of 22.20 degree. Epsilon 2 is 1 into sine of theta t, correct? So let us see how much theta t I am going to get. So using calculator, this is a sine of 22.20 into 2 sine inverse of answer 49 degree, right? So it is coming around 49 degree, right? So let us see whether theta t is 49 degree given or not. Theta t, yes, theta t is given as 49 degree. That means option B is absolutely correct. Transmitted angle theta I is how much? Theta t is how much? 49 degree. So I can say that option B is correct, right? So option B is correct, right? Option B is correct. Now let us come to the option number C. Option number C, what they are asking? Option number C, they are saying that what is the incident electric field? So the value has been given incident electric field, right? So incident electric field, you can see that the electric field is in this direction, right? So since HI is given, so we don't have to bother much to find the incident electric field. So option C, they are asking incident electric field, right? Now incident electric field can be found using the formula HI cross AK into eta, right? So this is the formula, or you can resolve the components directly. You can, since you know the magnetic field, so if you know the magnetic field, I can directly find the electric field. Otherwise, we have to resolve the components into two different components and then we can calculate it. So either of the way you can do it. So the most easy form is to use this formula, the electric field out of the magnetic field. So it is your HI cross AK into eta, right? Now here incident electric field, magnetic field 0.4 e to the power 10 to the power 90 minus of 3x minus of 3 times root 6 z in the direction of AY. Am I right? Right. So let us see whether I have written correct or not. So 0.4 e to the power j, both are in the negative, 3x and minus 3 root 6, right? So both are in negative, yes. Cross AK, right? Now what is AK? AK is nothing but the beta, A beta. Now here what you can observe here, so we have got beta. Beta is your 3ax plus 3 root 6 az, okay? See how to evaluate this AK, right? Okay, so one by one I will do, so better, okay. So just give me one moment. Here HI vector is this one. Now I want beta vector. So beta vector is how much? It is 3ax plus 3 root 6 az. Correct. Beta vector is same as k vector only. Correct. Beta vector is same as k vector. So what is your mod of beta vector? This is equal to root under 9 plus 3 3s are 9, 54. So let us see how much is the value I am going to get. 9 plus 54. So this is your 9 plus 54 root under 7.93. 7.937, is it? 7.937 mod of beta. So therefore what is your AK cap? So this is nothing but your mod of k vector. So therefore what is your AK? It is your k vector upon mod of k vector. This is how much? It is your 3 times of AX plus 3 root 6 times of AZ divided by 7.937, right? So we have got the value of AK also. Now we have to find the value of eta. Eta is, it is in medium, so 120 pi upon root under epsilon r, because mu is equal to 1. So this is your 120 pi, and how much is your epsilon r? Epsilon r, it is in the first medium incident, so it is 4, so divided by 4, that means 2. So this is how much? It is a 60 pi. So I have got all the values. Now I need to substitute these values in this particular equation. So therefore the incident electric field EI, okay, I think there is no space, so better I write little down, right? So therefore incident electric field HI 0.4 e to the power j 10 to the power 90 minus of 3x minus of 3 root 6 z in the direction of AY, right? Cross AK. AK is your 3AX plus 3 root 6 AZ divided by 7.937 into eta. So eta is how much? 60 pi. Right. So this is the value I am going to get. So here EI is equal to, Now you can see that, so let us calculate some value. 0.4 divided by 7.937 into 60 pi, 9.499. So I can approximate it as 9.5, let us say 9.5 e to the power j 10 to the power 90 minus of 3x minus of 3 root 6 z, right, ay cross ax. So this is a 3 times minus of az, because y cross x is minus az, plus 3 root 6 ay cross az, this is your ax, correct. So incident electric field ei is equal to, so I am writing approximately because we will equate with the, so it is coming around 28.5, right. So I am just approximated, right. So and we can then compare with the actual options. Az plus 9.5 into 3 root 6, 69.8, right, ax e to the power j 10 to the power 90 minus of 3x minus of 3 of root 6z, is it? So this is the value I am going to get. Fine. So if I rearrange, so if I take the e I, it can be taken, if you take in the real terms, so it will become 69.8 ax minus 28.5 az, right. If I take the real term, so it will become cos of 10 to the power 90 minus of 3x minus of 3 times root 6 z volt per meter. So this should be the answer. So let us see whether option C is correct or wrong. So see, first of all I will check the magnitude. So 69.8 ax 28 minus 28.5, where it is 69.75. okay, so I can approximate because we have already taken the approximation, I told you. So that means 69.8 ax minus 28.5. now rest is your 10 to the power minus 6, so option C is exactly correct, right. So I am getting the same value, cos 10 to the power 90, because they have taken the real term. We have not taken, we have considered as according to the e to the power j, right. So because it is they have basically not taken the in the options, if you see that they have taken the real term, so we have taken the real part, right. So that means this is the option C is correct. So if you recheck, so this is your 69.75 they have got, we have got 69.8, so it is fair enough, and minus of 28.5, rest is same. So that means option C is absolutely correct, there is no doubt about it, right. Now coming to the option number D. So what is option number D? Option number D is reflected electric field. So they are asking ER is how much, correct. So let us check how much is the electric field reflected one. So option D. Option D, they are asking what is the reflected electric field, right. So again I will redraw the figure here for better understanding. The wave is going like this, correct. Now let us see what is the direction of the electric field they have given, right, because they are interested in electric field. So let us see what is the direction of the electric field they have given. Okay, electric field is downward, right. Okay, fine. So electric field is in downward direction, so I will take that downward direction, right. That means electric field is in this direction, this is ER. This angle is a theta r, so theta r, right, and this is a theta I, correct. This is a theta I, and we know that theta I will be equal to theta r, and I think it was 22.20 degree, correct. So theta I was how much? It was a 22.20 degree, is it? 22.20. So I will recheck once again, so that we don't have any, yeah, 22.20, correct. So theta I we have taken 22.20. Now there is a reflected wave. So reflected wave, we have two components, right? So one component I can get fine, okay. So if this is 90 degrees, so this is your 90 minus theta r. So this will be 90 minus theta r. So this angle will be how much? It will be your theta r, right? So this angle will be your theta r, correct? Fine. This value, okay, now we have to check beta also. So let us say I will put theta r. So this angle is a theta r, right? Fine. So how much is this one? This is your ER naught into cos of theta r in the direction of AX, because this is the X and this is the Z. And how much is this one? This is your ER naught into sine of theta r in the direction of AZ, because both are in the positive. X and Z is given like this, right? In the question, if you see that the X and Z, this is how the figure has been given in the question. So you can see here carefully. So this is your Z axis and this is the positive X axis, ER is there, right? Now if I talk about beta, so let us check about the beta also, right? Beta, beta, this is the beta, right? So beta will be same, right? So this is your beta, this is your beta, correct? This angle is how much? So this angle is your 90 minus theta r, just now we have seen. So this angle is your 90 minus theta r, right? So this is your beta Z in the direction of minus of AZ, and this is your, or we will write this component, it is your beta X in the direction of AX, and this component is your beta Z in the direction of minus of AZ. Beta vector, right? So you can see that what is the beta vector now? Medium is same, right? So beta vector is equal to beta X AX minus of beta Z AZ, correct? So beta X AX minus beta Z. Beta X beta Z already we have calculated. It is your 3AX minus of 6 times, sorry, 3 root 6 minus of 3 times root 6 times of AZ, right? So this is the beta, right? What is R vector? So R vector will be your X AX plus Z AZ. So therefore what is your beta dot R? So beta dot R, it is equal to 3x minus 3 root 6 times of Z, correct? So therefore e to the power j omega t minus of beta r, it can be written as e to the power j 10 to the power 90 minus 3x plus 3 root 6 Z, correct? So this is the value I am going to get. Fine, okay. Now we have to find the value of ER, right? So now ER vector is how much? It is your ER naught, I can take common. It is your cos of theta r in the direction of AX plus sine of theta r in the direction of AZ e to the power j 10 to the power 90 minus of 3x plus 3 times root 6 Z, correct? Now we have the value theta r. So ER is equal to ER naught cos of theta r is your 22.20 degree in the direction of AX plus sine of 22.20 in the direction of AZ e to the power j 10 to the power 90 3x plus 3 times root 6 z. Fine. So let us see how much is cos of 22.20. So cos of 22.20, right. So further I can write it like this. See, the solution I am showing, it is elaborate, right. It is elaborate means to each and every point I am justifying, each and every point I am showing actually, right. So when you are well versed, you can easily skip plus sine of 22.20, 0.377 az, e to the power j 10 to the power 90 minus of 3x plus 3 times root 6 into z. Right, now I have to find the ER naught value. So until and unless I can find the ER naught, we cannot move ahead. Now, so how to evaluate ER naught? So for this I want gamma. Now gamma we have to find. Now the question is, because gamma will be how much? Now first of all, let us see whether it is parallel polarization or perpendicular polarization. So if you look at the diagram, if you go for the main diagram also, what you can observe here, the electric field is lying on the plane of propagation, right. So this is the electric field which is lying on the plane of propagation. So this is a parallel polarization. If the electric field was like this, right, if the electric field was something like this, then it is perpendicular polarization, because the electric field would have been perpendicular. So here electric field is lying on the plane of propagation, so it is a parallel polarization, right. So therefore I have to apply the reflection coefficient for the parallel. Right. So gamma parallel, how much is the value? It is given as sine of 2 theta t minus of sine of 2 theta I divided by sine of 2 theta t plus of sine of 2 theta I. You can use other formula also, that is eta 2 cos theta t, those big formula, minus cos eta 1 cos theta I. So that formula also can be used, right. So here both are going to give you the same value. Sine of 2 theta t is how much? 49 degree, I guess, right. Theta t, let me check once for the zero error. Yeah, 49 degree minus sine of 2 times of 22.20 divided by sine of 2 into 49 degree plus sine of 2 times of 22.20, right. So let us see using the calculator. This is your sine of, where is sine? Sine of 2 into 49 minus sine of 2 into 22.20. This is coming to be 0.290 divided by, now what I have to do, I have to just simply represent negative with the positive sign, 1.689, right. So 0.290 divided by answer. So I am getting 0.171, 0.171 you can say, right. So what is gamma parallel? It is equal to how much is reflected to how much is incident. It means that how much is reflected, it is equal to gamma parallel times of EI naught, correct. But we don't know EI naught. So what is your EI naught? EI naught is equal to eta times of HI naught, correct. So eta is how much? It is your 120 pi upon root under epsilon r into HI naught, because this EI naught is the medium one. So this is a 120 pi upon 2 and it was a 0.4, correct. So this is how much? This is 60 pi into 0.4, 75.39, 75.39, right. So I have got the value of EI naught, right. So eta, since medium is your dielectric, so that is why I have to divide by root of epsilon r. HI naught, it is given as 0.4, right. So therefore what is your ER naught? So because we are left with only this value ER naught, So ER naught is equal to gamma parallel is how much? 0.171 multiplied by 75.39. So multiplied by 0.171. I am getting 12 point, around approximately I will write 12.9. Right, so this is just approximate because the options are given, so we will match. So decimal point, it is, if there is no much difference, there is no issue. Right, so therefore what is the value of ER vector? ER naught is around 12.9. right. This is a 0.925 AX plus 0.377 AZ. Now it is e to the power j 10 to the power 90 minus of 3x plus 3 times root 6 times of z. Right, so I need to multiply this. So 12.9 multiplied by 0.925, 11.93. So this is just approximately, right. So this is because I will check with the options which is more closer to this, that will be your answer, right. And then we have 12.9 multiplied by 0.377, 4.86 AZ, e to the power j 10 to the power 90 minus of 3x plus 3 root 6 times of z. Can I write it like this? Right. So therefore, what is your ER? ER can be written as 11.93 AX plus 4.86 AZ cos 10 to the power 90 minus of 3x plus 3 root 6 times of z volt per meter. So this should be the answer, right. Now let us see the option 11.93 and 4.86. So minus 3, this is matching 11 by 4.86. Okay, 4.86 can be corrected like this. So there is basically very minor difference. So I think we should correct this option to around 12. Let us consider this is 12.00. Because in the GATE exam the variation will not be much. Now since we are getting 11.93, some might get 12, that is okay, right. So the difference will not be that much, right, because they will verify it. So there is some printing error or typing error. So you just consider it to be either you can take 11.93 or let us say it is around 12, right. So approximately, or better what we can do is, let us make it to be correct. So there is some printing error or typing error. So just make it as, so I will just 1 second. Right, because in the GATE exam the difference, there cannot be any conflict in the options. So better let us write 11.9, right. Let us write the option as 11.9, right. So hence option D will be also correct, right, because in the exam if I am getting 11.9, in the option maybe they will give you now we have got how much, 11.93, right. So in the option they might give you 12 or 11 point something, they will not give you very much difference, right. So there is some typing error, so it was actually around 11.9. so option D is also correct, right. So for plus 4.98 and both are same, fine. So which option, so this option D is also correct. So I can say that option D is correct, right. So that means I have got the answer as B, C and D. Correct? So answer will be B, C and D. Coming to the next question. This is question from antenna. The question reads as, a 3-element uniform array is to be designed to get maximum radiation in the broadside direction. There is an interference source located in a direction of 30 degrees from array axis. This interference is to be completely suppressed by placing a null in the direction of the interference source. The minimum array spacing is what? Right. So how many elements are given? You can see that there are 3 elements. Correct? Fine. And this is your broadside direction. That means this is a broadside array, right? Okay. So they are asking what is the minimum array spacing. That means if there are 3 elements, what should be the minimum array spacing, right? Now we know that in the question they are saying that it is your broadside array, isn't it? Which type of array? It is your broadside array. Correct? So broadside array, it means that alpha we take to be 0, right? So for broadside array, alpha is how much? So alpha we take to be 0, isn't it? Okay. Now psi is equal to alpha plus beta d cos theta. Alpha is 0, so this is equal to beta d cos theta at alpha is equal to 0. Correct? So at alpha is equal to 0. So therefore this is how much? It is your 2 pi by lambda into d into cos theta. Correct? Now they are saying that there is an interference source located in a direction of 30 degree, right, from the array axis. This interference is to be completely suppressed by placing a null in the direction. So that means here theta, if I put cos theta, right? Okay, so let us say this is equation number 1, right? Now for null, what happens? For nulls, we know that psi is equal to plus minus 2 m pi upon capital N, where m start from 1, 2, 3. We cannot put m equal to 0, otherwise it will give you the maximum direction of the radiation, right? So for the multiple array psi, correct? So here psi is equal to plus minus 2 m pi. N is how much? It is 3, where m will start from 1, 2, 3. Now this is equation number 2, right? So this psi and this psi should be same because I have to put the null. So this is psi. So I can say that 1 and 2 both should be same. So if 1 and 2 are same, I can say that 2 pi by lambda into d, 2 pi by lambda into d into cos. So null is placed in which direction? It is placed in the direction of 30 degree, right? So it is placed in the direction of cos of 30 degree is equal to plus minus 2 m pi upon 3, right? So any values that are getting cancelled? I hope things are clear till here. So you can see that this 2 pi is getting cancelled, right? Cos theta. So d upon lambda cos theta is how much? It is root 3 by 2 is equal to plus minus m upon 3. So for minimum array, I have to put m equal to 1, right? Because they are asking what is the minimum array spacing, right? So for minimum m is from 1, 2, 3 and so on. So for minimum m should be equal to 1. So therefore d root 3 upon 2 lambda is equal to plus minus 1 by 3, right? So they are asking d. So d is equal to plus minus 2 lambda upon 3 root 3. Now distance cannot be negative. That means it is a plus of 2 lambda upon 3 root 3 and this is your minus 2 lambda upon 3 root 3. We know that distance cannot be negative, so we have to take distance to be positive. So what is the value of D? So therefore minimum spacing is how much? It should be 2 lambda upon 3 times root 3. So this should be the answer, isn't it? So answer should be 2 lambda upon 3 root 3. So this is what? So 2 lambda upon 3 root 3. So there is only one option. So this is your option D is correct. So option D. I hope things are clear to everyone. Next question. Next question is saying that the cutoff frequency of a dielectric field rectangular waveguide for TM11 and TE30 modes are both equal to 15. So that means cutoff frequency for TM11 and TE30 modes both are 15 gigahertz. If the dielectric has epsilon equal to 4 epsilon naught, then the dimensions of the waveguide is what? So this is your MCQ. Correct. Now first of all I will consider TE30, right, because here I can get TE30 if I consider. So cutoff frequency of TE30 will be how much? It is your V upon 2 root under M upon, or first of let us write the cutoff frequency formula. So M upon A whole square plus N upon B whole square, right. Here V will be C if I talk in terms of air, and this will become C upon root under epsilon r if I talk in terms of some lossless dielectric, right. Here clearly they have given the dielectric as 4 epsilon naught, so TE30, right. Okay, so for TE30 cutoff frequency at TE30 will be how much? C upon 2 under root under epsilon r root under 3 upon A whole square plus N is your 0 upon B whole square, right. So this is how much? It is your 3 into 10 to the power 8 divided by 2 into root of epsilon r is how much? It is 2 into 3 upon A, right. So this is how much? 3 3s are 9 by 2, 4.5. So 1.25. That means it is okay. So this is your 9 into 10 to the power 8 divided by 4A. Now here cutoff frequency is given as 15 gigahertz, right. So as cutoff frequency of TE30 is given how much? It is 15 into 10 to the power 9. So therefore this is your given, right. So I can say that 15 into 10 to the power 9 is equal to 9 into 10 to the power 8 upon 4A. So from here I will get the value of A, right. So A value is how much? It is 9 into 10 to the power 8 divided by 60 into 10 to the power 9, right. So let us calculate the value using calculator. So this is how much? 9 to the power 8 divided by 60 to the power 9. So I am getting 0.015 meter, 1.5 centimeter. So let us see, any option is there with 1.5 centimeter? Okay, there are two options, 1.5, there are two options. That means any answer from A or B will be correct, right. So we need to check which is correct one. Right, fine. Okay, similarly now next mode is what? It is TM11, correct. So now for TM11, now cutoff frequency of TM11 is equal to, this is your 3, I will directly write the formula. So this is your the C upon 2 root under epsilon r root under 1 upon a whole square plus 1 upon b whole square, right? So it was TM11. So both 15, okay, fine. So this is how much? It is your 3 into 10 to the power 8. Okay, let me consider in the centimeter only, because they have options I have given in centimeter. 2 into root of epsilon hours, it was 2, 1 upon a. 1 upon a is 1.5 whole square plus 1 by b whole square. Correct. So this is how much? So this cutoff frequency is given as 15 gigahertz. Yes. So therefore 15 into 10 to the power 9 is equal to 3 into 10 to the power 10 divided by 4 root under 1 upon 1.5 whole square plus 1 upon b square. So from here I will get the value of b, right? So this is how much? 60 into 10 to the power 9 divided by 3 into 10 to the power 10 whole square minus 1 upon 1.5 whole square is equal to 1 upon b square. So from here I will get the value of b. So let us calculate using calculator. So this is your 1.5 so I am getting 0.5. If you calculate using calculator, I am getting 0.53. So here options are given in terms of 0.5. So I am getting how much? 1.5 centimeter. Here we have got the value of A and here we have got the value of B. So 1.5 into 0.5. Which option is correct? 1.5 into 0.5. Option B is the correct answer. So option B is 1.5 into 0.5. So option B. So next question. A wave propagating in a lossless dielectric has the components E vector is given 500 cos 10 to the power 70 minus beta z ax and H vector is given as 1.1 cos 10 to the power 70 minus beta z ay. If the wave is traveling at a velocity 0.5 c, that means 0.5 into speed of light, then the relative permeability of the medium is how much? Correct. Okay. Now how to solve this? Now what is given actually? Given is E vector which is equal to 500 into cos of 10 to the power 70 minus beta z ax. How much is the H vector? 1.1 into cos of 10 to the power 70 minus of beta z in the direction of ay. They are asking to find the value of relative permeability, means mu r is equal to what? Correct. So this question has been given. Now how you will do it? We know that mod eta or eta is equal to, you can so it is a lossless medium. So sorry, now as eta is equal to mod of E upon mod of H. So this is equal to 500 upon 1.1. So 500 upon 1.1 is how much? So 500 upon 1.1, 454, okay, 454.54, good number, 454. Correct. Okay. Now eta is nothing but your 120 pi root under mu r upon epsilon r. Now since there is no alpha or no theta eta term, that means the medium is lossless medium. It can be free space, it can be lossless dielectric, right? So mu r epsilon r, this is how much? It is equal to 454.54. So from here I will get the value of mu r upon epsilon r. So divided by 377 whole square, 1.453. Correct. Let us say this is equation 1. Correct. Okay. Next. Now V is given as 0.5 C. What is V? V is equal to C upon root under mu r into epsilon r is equal to 0.5 times of C. So therefore I can say that, or you can say that this is C by 2 directly, you can say C by 2. So I can say that mu r into epsilon r, mu r into epsilon r is equal to 2. So I can say that mu r into epsilon r is equal to 4. Say this is equation number 2. So if I multiply 1 and 2, 1 multiplied by 2, mu r upon epsilon r into mu r into epsilon r, 1.453 multiplied by 4, right. So here you can see that epsilon r is getting cancelled. So from here you will directly get the value of mu r. So into 4 root of answer, I am getting 2.41. 2.41. So this should be the answer. Correct. So answer is 2.41. So answer is your 2.41. This should be the answer for this particular question. Right. In the GATE examination, they will give you rounded up to 2 decimal point, rounded up to 3 decimal point, rounded up to 1 decimal point. They will clearly mention. Here in the question, they have not mentioned whether you have to take 1 decimal, 2 decimal, 3 decimal. So I have taken arbitrarily. How many decimal I have taken? 2 decimal. Right. Okay. So I hope things are clear, everyone. Okay. So next question. Next question. Let us read. So the question says that a 50 ohm transmission line operating at 250 megahertz frequency is terminated by the series combination of a 75 ohm resistor and a variable capacitor. The value of capacitor C that will produce a standing wave ratio of 7 on the line is how much picofarad, right? So this is the question that has been given. So let us see how to solve this question. See what the question is saying, that we have a transmission line. Let us say this is the transmission line. Characteristic impedance is how much? It is 50 ohm. A 50 ohm transmission line operating at, so operating frequency is how much? 250 megahertz. Is terminated by the series combination of, okay, so it is a combination of series combination of a resistor and a capacitor, and this capacitor is variable. So this is C and this is R, and this R value is given as 75 ohm. Correct. By the series combination of 75 ohm and a variable capacitor, the value of capacitor C that is going to produce, so they are asking what is the value of C, so that the standing wave ratio is how much? It is 7, right. So what should be the value of capacitance, so that I will get the standing wave ratio as 7, right. So now how to do this? Now what you can see here, standing wave ratio is how what they want? 7. So I can say that mod of gamma is equal to S minus 1 upon S plus 1. So this is how much? 7 minus 1 upon 7 plus 1. This is equal to 6 upon 8. That means 3 upon 4. Right. 7 minus 1 6, 7 plus 1 8. So 2 3s are 2 4s are. Right. So how much I am going to get? I am going to get 3 by 4. Now here capacitance is basically they are asking what is the value of capacitance. Gamma, we know that it is equal to ZL minus Z0 upon ZL plus Z0. What is ZL? ZL is equal to R minus JX minus Z naught is your 50 divided by R minus JX plus 50. Can I write it like this? R value is given in the question, it is 75. So 75 minus JX minus 50 upon 75 minus JX plus 50. This is how much? It is a 25 minus JX and this is a 125 minus JX. Right. So can I write it mod gamma? Mod gamma will be how much? 625 minus of plus of x square, correct, root under divided by 125 square is how much? Where is the calculator? So 125 whole square, 15625 15625 plus x square. If I consider this to be equation 1 and if I consider this equation 2, can I say both 1 and 2 should be same? Right. So from here I will get the value of x, and x is nothing but the reactance only. Right. So I can say that 1 is equal to 2. Correct. So therefore I can say that 9 by 16 is equal to 625 plus x square, 15625 plus x square. Correct. So 1 and 2 both will be same. I hope things are clear till here. So from here I can say that 9 multiplied by 15625 plus 9x square is equal to 16 multiplied by 625 plus 16x square. So therefore I can say that calculator 15625 into 9 minus 16 into 625, 130,625 is equal to 60 minus 9 is 7x square. So divided by 7, root of answer. So I am going to get the value of x is equal to 136.604. Now x is equal to 1 upon omega c is equal to 136.604. Right. So from here I want the value of c. It is equal to 1 upon omega multiplied by 136.604. Omega is equal to 1 upon 2 pi. Frequency is given in the question. How much is the frequency? 250 megahertz. So it is a 250 mega 10 to the power 6 into 136.604. So from here I will get the value of capacitance multiplied by 250 to the power 6 into 2 pi. So 1 divided by answer. I am getting 4.67 picofarad. So capacitance I am getting 4.67. So this is what? NAT or what? Yes. So answer should be how much? 4.67. Right. So answer should be 4.67 picofarad. Fine. Okay. Next question. A 9 gigahertz signal is to be transmitted inside a circular waveguide. Correct? The radius of the guide so that its lowest cutoff frequency is 25% lower than the applied signal frequency is P11 is given as 1.841. Now this is a circular waveguide, right? Now what the question says that a 9 gigahertz. So what is the operating frequency given? It is 9 gigahertz. The radius of the guide so that its lowest cutoff frequency is 25%. So lowest cutoff frequency is 25% lower than, that means it is 0.75 times of signal frequency 9 gigahertz. right? Then they are asking what is the A, right? So radius of the guide. Now so we know that dominant mode in circular waveguide, right? So if nothing is mentioned, we always take the circular waveguide. The dominant mode is T11, P11 pole is given. So dominant mode in the circular waveguide is T111. So therefore I can say that the cutoff frequency of TE11 is equal to x dash and P into C. Is there any dielectric? No. Upon 2 pi. Correct? So this is the value you are going to get. So this is how much? Here P is given as 1.841 multiplied by 3 into 10 to the power 8 divided by 2 pi into A. Correct? Now this cutoff frequency is given as 0.75 into 9 into 10 to the power 9 is equal to 1.841 into 3 into 10 to the power 8 divided by 2 pi A. So from here I can easily calculate the value of A. So A value is equal to 1.841 into 3 into 10 to the power 8 divided by 2 pi into 0.75 into 9 into 10 to the power 9. So let us calculate this value using calculator. Right, so calculator we have to use 2 pi into 0.75 into 9 to the power 9, 1.841 into 3 to the power 8 divided by answer. So I am getting 1.3 centimeter. This should be the answer because option has given in the centimeter. So 1.3 centimeter is the correct answer. So option B is the correct answer. Option B will be the correct answer. Now coming to the next question. Next question is saying that a half wave dipole antenna is to be operated at 600 megahertz. The length of the antenna required if it is operated under C, epsilon value is given as 81 epsilon naught, mu is equal to mu naught, sigma is value is given 4 Siemens per meter, is how much? Rounded off up to 2 decimal point. Okay. So here length is given as lambda by 2, right? Fine. Operating frequency is how much given? It is given as 600 megahertz. The length of the antenna they are required, so it is operated under C. Now C, let us see that for sea water, right? So for sea water they have given epsilon is equal to 81 epsilon naught, mu is equal to mu naught and sigma is equal to 4 Siemens per meter. So first of all, to find this lambda, because length they are asking, right? So length is equal to lambda by 2. So first of all we have to find what is the value of lambda, then only we can do anything. Correct? Okay. So for sea water, sigma upon omega epsilon, this is how much? Sigma is given as 4 upon omega 2 pi. Operating frequency is 600 megahertz. So this is a 600 into 10 to the power 6, right? Omega epsilon naught. So this is 8.85 into 10 to the power minus 12 into epsilon r is how much? 81. So let us calculate this value, how much we are going to get. So this is your 2 pi into 600 to the power 6 into 8.85 to the power minus 12 into 81. So this is 4 divided by answer 1.48. So I am getting 1.48. Now 1.48, that means it is your partially conducting medium, right? So what this signify? So this signify it is your partially conducting medium. It is your partially conducting medium. So if the partially conducting medium, I want what? Lambda. So therefore beta will be how much? It is given as omega root under mu epsilon upon 2 root under 1 plus sigma upon omega epsilon whole square plus 1, right? This can be written as omega upon root 2 into c root under mu r into epsilon r root under 1 plus sigma upon omega epsilon whole square plus 1. Can I write it like this? Fine. So therefore beta is equal to omega, that is 2 pi, frequency is 600 megahertz, isn't it? Yes. So 600 megahertz, 600 into 10 to the power 6 upon root 2, c is how much? It is 3 into 10 to the power 8. Correct. Root under mu r is 1, epsilon r is your 81 into root under 1 plus sigma upon omega epsilon 1.48 whole square plus 1. So let us calculate this value. So this is a 1.48 whole square, 1.48 plus 1. So root of answer plus 1 into 81 root of answer into 2 pi into 600 to the power 6 divided by root 2 into 3 to the power 8. 133.487, right? So once you know the beta value, so I can say that beta is equal to 2 pi by lambda. So from here I will get the value of lambda, which is equal to 2 pi by beta, right? So this is same as 2 pi upon beta is how much? It is 133.487, right? So 2 pi divided by answer 0.047, correct? So lambda. So therefore what is the length? Length is given as lambda by 2, 0.047 by 2. So divided by 2, 0.023 meter. So this is given in centimeter or meter. Let me check. Meter. So and rounded off up to 2 decimal point. Okay. So 2 decimal point. So this is a 0.02 meter. Correct. So this should be the answer. Fine. So with this we conclude our GTQ session. I hope you have learned, you have revised and you have understood well. So all the best for your coming GATE examination and various other examination. So all the best. So a vote of thank from my side. So thank you everyone for kindly listening and understanding the concept. So thank you.